Hello geometry students. In this video we're going to work through some problems together to help you with your Cycle 4B project. So grab a pencil and let's work through these. And the point of this project is to be able to solve proportions that involve quadratics. We're eventually going to have to solve a quadratic equation. So we're going to kind of step our way to that point to solve a problem like if you look at number 5 on your worksheet. Let's just step our way to that by starting with just practicing the skill of multiplying a binomial times a binomial. So this binomial has two terms, this binomial has two terms. So we're going to have to take two terms times two terms. That'll be a total of 4 multiplications, and you can do it any way you want. Some people like FOIL, some people like the box method. They're all the same thing. What those methods are doing is we're going to just use the distributed property as many times as we need to until we've done all 4 multiplications. So we're going to start with x, and what we're going to do with x is we're going to distribute it to the other set of parentheses. You want to multiply x by both terms in the other set of parentheses. So x times x gives us x squared, and then when we take x times -3, that's going to give us a -3x. Now at this point you're done with the x because you've multiplied it times both terms in the other set of the parentheses. So now let's move on to the 7 and let's distribute it. So first we're going to take 7 times x, which gives us 7x, and then we're going to take 7 times -3, which would give us -21. Now at this point you'll see that there's some like terms that need to be combined. So our final answer will be x squared plus 4x minus 21. Now my goal for you is to get you to the point where you can go from this step to this step without writing this middle step down. It'll save you a lot of time. So what you need to be able to do is keep track of these terms in your head. So let's try that on this next example. So let's take a look at number 2. So we're going to start by distributing this x. We're going to multiply it by both terms in the other set of parentheses. So when I take x times x, I'm going to get x squared. And now is where you need to keep track, because we're going to next take x times -6. So you need to hold that -6 in your head, because you're going to combine that with -9 times x, which is -9x. So this is what you're keeping track of in your head. The product of the outside terms plus the product of the inside terms. -6x plus -9x is -15x. And then the last thing we need to do is continue distributing the -9, so we need to multiply that -9 times this -6 for a final answer of 54. Now in this next problem, number 3, we're going to solve this quadratic equation by factoring, okay? So what we need to do is we need to take this trinomial and factor it into 2 binomials. So when it comes to factoring, you want to start by putting 2 sets of parentheses. So we're going to write 1 set of parentheses times the second set of parentheses equals 0. So now let's go ahead and factor this trinomial into the 2 binomials you would multiply together to get that trinomial. So I think everybody knows that since this first term is x squared, the first term of each of your binomials needs to be x, okay? So then the next thing I look at is I look at this sign right here. Because remember, this 26 is the result of multiplying 2 numbers together. So if I multiply 2 numbers together and I get a positive 26, what that tells me, that positive sign tells me that the signs have to be alike. If that sign is positive, that last term is positive, that means that my signs are alike, okay? Then the next thing I look at is this term. Now remember, this is the sum of 2 terms, so if I have 2 signs that are alike and the sum is positive, that means that both of those signs have to be positive. So I'm going to put a plus and a plus, okay? And so the next thing I need to do is I need to think of factors of 26 that add up to 15. So some people like to make a list, so if you want to do that, you could make a list and think of all the factors of 26. So for example, 1 and 26, well that's not what we're looking for because they don't total 15. So let's try another set of factors. How about 2 and 13? Bingo, that's what we needed. 2 and 13, when you multiply those two numbers, you get 26. When you add them, you get 15. So we're going to write x plus 2 times x plus 13 equals 0. Now the next thing we're going to do is use a property called the zero product property. And here's what that property says. It says, I'm just going to write it over here, if you multiply two things together and get 0, if a times b equals 0, then either a equals 0 or b equals 0 or both. So that's what's happening here. We're multiplying two things together and the result is 0. So the only way that can happen is if one of those factors is equal to 0. So either x plus 2 equals 0 or x plus 13 equals 0. So we'll write that out. Either x plus 2 equals 0 or x plus 13 equals 0. And then we'll solve each of those equations and we'll get x equals negative 2 or x equals negative 13 for our two solutions. So let's solve by factoring again in number 4. So we have a trinomial set equal to 0. So to solve this by factoring, we're going to first of all write two sets of parentheses being multiplied together equals 0. To find the two binomials, we multiply together to get this trinomial. So if this term is x squared, then that means this term has to be x and this term has to be x. So we're going to put an x here and an x here. Now, take a look at this sign, which is negative, and that negative 40 is the result of multiplying these two numbers together. So if I multiply these two numbers together and get a negative, that tells me that the signs have to be different. So if this sign is negative, okay, that tells me that my signs are different. Okay, so one of them is going to be a positive, one is going to be a negative. So now what we need to look for is the two numbers you would multiply together to get negative 40 that add up to negative 3. So if you think of negative 40 and making a list of all the possibilities, well, one has to be positive, one has to be negative. So we could think of either positive or negative 1 and positive or negative 40, or positive negative 2 or positive or negative 20, and that's not going to work. How about 4 and 10? Okay, again, we're looking for numbers that are going to be 3 apart. So 4 and 10 are going to work. But what about positive or negative, let me fix this, positive or negative 5. Okay, positive or negative 5, and either positive or negative 8. Now, those are 3 apart. So if we pick negative 8, let's see, negative 8 and positive 5, negative 8 times positive 5 is negative 14, and when we take negative 8 plus positive 5, that adds to negative 5. So we want our 5 to be positive and our 8 to be negative. Okay, so now that we've factored it, we'll set each factor equal to 0. Either x plus 5 is equal to 0 or x minus 8 equals to 0. So our two solutions then would be x equals negative 5 and x equals 8. So let's solve one more quadratic equation by factoring. So we're going to start, if we're going to factor x squared minus 7x plus 12 equals 0, we're going to start by writing two sets of parentheses, the product of two sets of parentheses, set that equal to 0. Okay, we know that since this is x squared, each of these binomials is going to start with x. So we have x and x, okay. This sign tells me the signs are alike, and this sign tells me that they're both negative. So I'm going to write minus and minus, and now I need factors of 12 that add up to 7. Well, again, you can make a list if you want to, but pretty quick you're going to find the factors of 12 that add up to 7 are 3 and 4. So since they're both negative, it doesn't matter where I write the 3 or the 4. So you can write them in either order. And then once we have this factored, now we'll use the zero product property and say the only way I can multiply x minus 3 times x minus 4 and get 0 is if either x minus 3 is equal to 0 or x minus 4 is equal to 0. So our two solutions are going to be x equals 3 and x equals 4. So now let's take a look at an example where we're not going to be able to solve by factoring. You can try as hard as you can, but you're never going to find factors of 3 that add up to 5. So if you have a quadratic equation and the trinomial cannot be factored, that's when we want to use the quadratic formula. So I've written it down for you so you have the quadratic formula, but I just want you to know what that means. What this means is if you have a quadratic equation in standard form that looks like this, ax squared plus bx plus c equals 0, so you have an x squared term, an x term, and a constant term, and that all equals 0, then we can take a and b and c, a being the coefficient of your x squared term, b is the coefficient of the x term, and c is the constant term, plug them into this formula, and then do the arithmetic, and you'll have your solutions. So in this example, our a, let's just go ahead and write down what everything is. A would be 1 because our coefficient of x squared is 1, and then b would be 5, and then c, the constant term, is 3. So now to find our solutions, we're going to just find the x's that produces the, oops, oh, I just did. To find the x's that produces 0, we're going to take a, b, and c and put it into this formula. Okay, so we first take the opposite of b. Well, b is 5. The opposite of 5 is negative 5. So negative 5 and then plus or minus the square root of. Now we're going to take b squared. So that would be 5 squared minus 4 times a, which is 1, times c, which is 3, and put that all over 2a, with that, which would be 2 times 1, okay? So this actually represents two solutions, negative 5 plus all this stuff over 2, and negative 5 minus all this stuff over 2. So all we really have left to do is to simplify this a little bit. So negative 5 plus or minus, this would be, let's see, 5 squared is 25, minus 4 times 1 times 3 is 12, and that's all over 2. So we're going to leave our answer like this, negative 5 plus or minus the square root of 13, and that's all over 2. So those are our two solutions. So on the project, when you're using the quadratic formula, I only put one blank because we write the two solutions together by using this plus or minus symbol. Okay, so now we have practiced all the skills so that we can solve a proportion like this one. You'll notice when we go to cross multiply, we're going to end up with the quadratic. So I'm going to go ahead, let's put these binomials in parentheses, and I'm going to go ahead and cross multiply this way. So what I'm going to be multiplying is x plus 9 times x plus 2. So we'll remember how to do that. We're going to start by distributing the x. So we would have x squared plus 2x, but remember, keep track of that 2x in your head. So this is going to be x squared plus 2x. Oops, hold on. I'm not going to write plus 2x because I'm just going to keep track of that in my head. And then we're going to take 9x plus 2. So remember, we had the product of the outside terms was 2x. The product of the inside terms is 9x. 2x plus 9x is 11x. So we're going to write plus 11x, and then we multiply 9 times 2. That gives us 18. So plus 18 is equal to the product when we multiply these two numbers. So 2 times negative 5 is negative 10. Now, this quadratic equation is not in standard form yet. Remember, to use the quadratic formula or to factor, we need one side equal to 0. So what I'm going to do is real quick add 10 to both sides, so I get one side is equal to 0, and we have x squared plus 11x plus 28 equals 0. So now we need to decide, are we going to solve this by factoring or using the quadratic formula? So look at this positive 28 and ask yourself, are there any factors of 28 that add up to 11? And there are 4 and 7. 4 times 7 is 28, and 4 plus 7 is 11. So I'm going to go ahead and factor the trinomial and set those factors equal to 0. Each of these binomials starts with x. I see that my signs are alike and they're both positive, so I'm going to put a plus and a plus. Now, factors of 28 that add up to 7, we said they were 7 and 11. So since they're both positive, I'm sorry, not 7 and 11, 7 and 4. Since they're both positive, you can put the 4 or the 7 in either spot. Doesn't matter. But then the next thing you want to do is set each factor equal to 0. and solve. So we get our two solutions are x equals -7 and x equals -4. Okay, let's try another proportion. We're going to solve number 8. So we're going to start by cross multiplying. So we're going to have to multiply x minus 6 times x plus 2. So you might just want to write that out over to the side. X minus 6 times x plus 2. So we're going to start by taking x times x. That gives us x times x gives us x squared. Okay, and then the outside terms give us, let's see, the outside terms give us 2x, and the inside terms give us -6x. So positive 2x plus -6x is -4x, so we'll write -4x, and then the last thing we need to do is take -6 times positive 2, and we get -12. Always be on the watch out for those signs. Remember, the sign in front of the term is part of the term, so make sure you take a -6 times x and a -6 times 2. Okay, oops, and I accidentally set that equal to 0. That's not right. We need to set that equal to the other cross product. So when I take 8 times 6, I get 48. Okay? And then we want to get this in standard form. We want one side equal to 0. So let's subtract 48 from both sides. So we'd have x squared minus 4x. -12 minus 48 more would give us -60, and then set that equal to 0. So now let's see if we need to factor or use the quadratic formula. So the question is, are there factors of -60 that add up to -4? Well, if you think of the factors of 60, -60, consider -10 and +6. -10 times +6 is -60, -10 plus +6 is -4. So this one is factorable. So let's go ahead and solve it by factoring. So we'll set up two binomials that each start with x. Okay, I look at this sign. This -60 is a result of multiplying two numbers. So if I have a negative product, I know these signs are different. So put a plus and a minus. And then remember we said our two numbers were going to be 10 and 6. So which one needs to be negative? Well, if I have a negative negative sum, I know that my bigger one has to be negative. So that 10 has to be negative and 6 has to be positive. So then we'll set each factor equal to 0. Oops. And oops, I got ahead of myself. We're setting each factor equal to 0. So x minus 10 equals 0. So our two solutions then would be x equals -6 and x equals 10. So now let's take a look at number 9. We're going to multiply. When we cross multiply, we're going to have to take a binomial times a binomial, x minus 8 times x plus 1. So remember, that's going to be a trinomial. We're going to start by taking x times x, which gives us x squared. And then we're going to take x times 1, which gives us x. So we're going to take the product of those outside terms plus the product of these inside terms. So 1x plus -8x is -7x. And then finally, -8 times +1 gives us -8. And then when we cross multiply the other way and take 13 times -1, we get -13. Now, next step is to get this in standard form. So we want one side equal to 0. So let's add 13 to both sides. And we get x squared minus 7x plus 5 equals 0. And now we have to decide where to go from here. Well, we're not going to be able to solve by factoring because there are no factors of 5 that add up to -7. So if there's no factors of 5 that add up to -7, then it's time to use the quadratic formula. So let me just jot it down again for you. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a, where in this case, a is your leading coefficient of 1. So a is equal to 1, b is equal to -7, and c is your constant term. It's equal to 5. So let's plug those numbers into the equation. So we're going to take the opposite of b. Now the opposite of -7 would be +7. So this is going to be 7 plus or minus the square root of. Now we need to take b and square it. Now be careful here. B is negative. So if we're going to square a negative, you might want to put that in parentheses and write negative 7 squared minus 4 times a is 1 times c is 5, and then all over 2a. So now we just need to do the arithmetic under the radical. That's going to be negative 7 times negative 7 is positive 49, minus 4 times 1 times 5 is 20, all over, oops, I put an a there. Let me fix that. We know what a is. A is 1. That should have been 2 times 1. Sorry about that. Okay, so our denominator is 2. And then simplifying a little bit more, we'd have 7 plus or minus the square root of 29 all over 2. And we'll leave our answer just like that. That represents two solutions, 7 plus the square root of 29 over 2 and 7 minus the square root of 29 over 2. And then let's take a look at one more example. So again, we're going to have to multiply a binomial times a binomial when we cross multiply. X plus 5 times x plus 4, okay? So that trinomial is going to be, let's take x times x and get x squared. And then the product of the outside terms plus the product of the inside terms would be 4x plus 5x, which is 9x. So that's going to be plus 9x, and then multiply the last terms. 5 times 4 is 20. Okay? And then when we cross multiply the other way, 7 times 2 is 14, so we'll set that equal to 14. Next step is to get it in standard form. We want one side equal to 0. So let's subtract 14 from both sides. Oops. So we have one side equal to 0. And we get x squared plus 9x plus 6 equals 0. So now the question is factoring or quadratic formula. Well, if we look at our trinomial, there are no factors of 6 that add up to 9, so it's time to use the quadratic formula. If you need to jot it down, a is 1 in this case, b is your coefficient of the x term, so that's 9, and c is your constant term, so it's 6. So to find our solutions, we take the opposite of b, so that would be negative 9 plus or minus the square root of b squared, so that's 9 squared, minus 4 times a is 1 again, times c is 6, and then that's all, the whole thing over 2 times 1. And then simplifying just a little bit, that would be negative 9 plus or minus the square root of 81, 9 squared is 81, minus 24 all over 2. And then we can simplify a little bit more. That would be negative 9 plus or minus the square root of, let's see, 81 minus 24 is 57 all over 2. Okay, so I hope these examples have helped you. If you still need some help or have any questions about this video or the project, be sure and come ask me and let me give you some help. And I will see you in class.